Hi everyone, so now we're going to be talking about stretches and shrinks for transformations of graphs. And in stretching and shrinking, you can either stretch vertically or horizontally and then shrink vertically or horizontally. When I think about stretching vertically, I think about making it taller or skinnier. And then if I stretch it horizontally, I would make it fatter or wider. And then shrinking it vertically would make it fatter or wider. And then shrinking it horizontally would make it taller or skinnier. So basically, they do basically the same thing. It just depends on where the number lands in your equation. So let's go through these equations that I have written out. So if we start with an original function of fx, now that can be any of your parent functions, like fx equals x squared or x cubed, square root of x, any of those parent functions that we've talked about in the previous video, can be fx. So if we have c times fx, where c is some number, then it's a vertical stretch of c. Now, if instead of c, if it's 1 over c, or basically if the number that's in front is a fraction or a number that is in between 0 and 1, then it's a vertical shrink, which makes sense. So if I multiply something by a whole number, it usually gets bigger, which means stretching. And then if I multiply something by a fraction or something less than 1, it usually gets smaller, a shrink. Now, horizontally, it actually goes opposite. So when we have numbers inside the parentheses with x's and multiplying them, then if I have f of x or f of c times x, as in this one right here, that's a horizontal shrink of c. So it's almost opposite of what we think, which, although it doesn't make too much sense, in the grand scheme of things, it does make sense because horizontally, things are always backwards. Remember in the last video, we were talking about shifting it left, right, up, down. When we shift it left and right, it's the opposite of what you would normally think. And then the same thing goes for your horizontal stretch. So instead of multiplying it by a whole number on the inside, you multiply it by a fraction on the inside, something that's in between 0 and 1, like 1 over c times x, and that's considered a horizontal stretch. So let's just start going through some examples now. The first example, the first two examples, what we want to do is take the equation and write a new equation based on the transformations that they give us. So the first equation says f of x is equal to the step function of x. And then we want to vertically stretch it by a factor of 2. So if I look at all of my options, my vertically stretched one is this one right here, where I'm multiplying a number by the entire equation, and it's on the outside of the parentheses, which means all I have to do is write a new equation, which we're going to just call g of x, but then multiply on the outside of the parentheses that 2, because I want it to be a vertical stretch of a 2. So my final answer is 2 times the step function of x. Sweet. Okay. Now for the second example, it's asking us to stretch it horizontally or expand it horizontally by a factor of 3. Now, when we want to stretch it horizontally, we have to use this one, this bottom one that you can see right here. And that tells me that what we need to do is actually make it a fraction inside the parentheses. So if you remember, x squared doesn't have parentheses right now, but what we can do is put, for our new equation, we're going to say g of x, and then we're going to put x squared inside parentheses, but with the squared on the outside, so everything gets squared. And so we know there's going to be an x in there, and then we want it to be multiplied by 1 over c, or 1 over what we want to stretch it by, which in this case is 3. So my final answer has that 1/3 in there, which means that my overall final answer is g of x is equal to 1/3 x all squared. All right. Okay, so that's how we write equations. Now for the third example, they give us a graph, and they want us to find the parent function and then write the equation for the graph. So this is I know my artistry is not great, but you'll be able to see this on your example sheet a lot better. This looks like a V, and when those graphs are V's, that automatically tells me that my parent function would be the absolute value of x. Because the absolute value of x, it looks like V's. But, and I'm going to show you on a graph, instead of this one's kind of stretched out or widened out. Normally, absolute values of x have a slope of 1 or -1 on either side, so they go up 1 over 1. This one goes up 1 over 2. So it kind of got flattened out a little bit, right? Now, remember how I said at the beginning of the video, the horizontal stretch and vertical shrink, or horizontal shrink and vertical stretch, are really similar? They actually are in a lot of ways. And so we could write this out in one of two ways. We can write it as a vertical shrink or a horizontal stretch. I'm going to write it out both ways just so you can see, but it won't matter on like your self-check or on the quiz. So for my blue equation, I'm going to call that g of x, and we know that it has to have the absolute value of x because that's what the graph looks like. And I'm going to start with my vertical. So we know that it shrunk vertically. So I'm going to scroll up here just a little bit so I can look at it. And I want to do this. I know I have a lot of arrows already, but if you can see the arrow I'm drawing right now, we're talking about the vertical. I want to do a vertical shrink. So that means I'm going to have a 1 over something times f of x. So in this example, I'm going to have 1 over 2 times my absolute value of x. The reason why I have it 1 over 2 is because what happened is instead of going up 1 and over 1, I went up 1 and over 2. If I would have gone up 1 and over 3, then it would have been 1/3. Or if I would have gone up 1 and over 4, then it would have been 1/4. And that's how we decide what's happening when we, that's how we decide what the number c is. Now I can, like I told you, I can write it a different way. I can write it as a horizontal stretch. So for a horizontal stretch, we use this bottom one right here that I've already kind of arrowed out. And that one is 1 over c times x with inside the parentheses. So I can actually write this as the absolute value of 1 over 2 times x. And that tells me the exact same thing. Sometimes this doesn't work to have it both ways, but the majority of the time, and I believe all of the questions on your self-check will act like this. So whether it's easier for you to do the vertical version or the horizontal version, it doesn't really matter. So those are my two options for answers. All right, and then the last example, we want to sketch the graph of the function. So the graph is 1/2 absolute value of x, or not absolute value, but the square root of x. So what I'm going to do when I graph these, the easiest way for me to do it is to actually just start by graphing the parent function, which in this case would just be the square root of x. So the square root of x starts at 0, 0, and then it goes up to 1, 1, and then it'll go over to 4, 2, and it kind of just curves out like that. You have a parent function graph with you on your little cheat sheet, so you can definitely use that for these. Then, because it has that 1/2 in front of it, what that tells me is that, let's just double check, because it's not inside the square root, we know it's going to be vertical, and because it's a fraction, we know it's going to be this vertical shrink one, which means that it's a vertical shrink, so of 1/2. So what that means is it's going to get wider and fatter, and so I'm going to do it in this red color now. What happens is instead of going up 1, instead of going up 1 and over 1, then we're going to go up 1/2 and over 1. And then instead of going up another 1 and over 4, we're going to go up 1 more half and over 4. So it just kind of cuts all the vertical portions in half. And we end up looking kind of like that. All right, and like I said, remember we talked about that the horizontal and vertical are really similar. Sometimes you want to just double check that. So like in this case, the horizontal, if this one's asking for a vertical shrink. Great, we did that because all we did was shrink down each vertical number or each y portion or y point by 1/2. But the horizontal wouldn't have done the same, because if I would have done the horizontal stretch, that would have made it go up 1 and over 2, which still would have flattened it out, but it would have been, it wouldn't have looked the same. So you want to make sure that You're just double checking that either both of them will work, and if they don't both work, then which one works the best. All right, and there we have it. That is how we deal with horizontal, vertical stretches and shrinks.